All right, so essentially, we kind of talked about the tea lady yesterday, and what convinced us of the tea lady was the fact that she guessed them all correctly and heard that chances of her doing that by chance alone are really, really small. Okay? So, in an experiment, when we see differences in our treatment groups that are unlikely to occur by chance, then we can say those differences occurred as a result of the treatments. In other words, we can conclude a cause-effect relationship. If we've run that experiment and with randomly assigned treatments, okay? So, like, the big idea is about, like, what can we conclude about who? So at the end of a study, what can you conclude? What I want you guys to think about is, like, the end of that study, you can conclude based off the design of the study in the first place. That's why we care so much about what the design of the study is. Okay, so if we have random selection, that is a random sampling design, like how the participants were picked in the first place, okay? Then we can assume that the sample is representative. And if the sample is representative, we can generalize to the population. So, right now, for those of you at home, in this classroom right now, I have 3 seniors who are taking AP Stats. So if I did a study on just the 3 of you, I would not be able to say, oh, whatever happens in this study is true for all of Grandview Heights High School. Because you guys are not a random sample of Grandview Heights High School. That's what I mean when I say generalize to the population. Everybody good? All right. Now, if we have random assignment, now we're talking about, well, random assignment only happens in experiments. And the whole point of random assignment is your treatment groups. The only difference between the different treatment groups is the treatments themselves. So the treatments are the only difference. So if we see, if after the treatments we see a significant difference, that suggests cause and effect. So going back to this whole music thing, okay? So does music get in the way of, like, does it help you focus or not help you focus, right? Okay, so if my design is I'm getting all the students in my AP class to participate in a study, ask them whether or not they study with music on, and then look at their answer to the question. So basically, like, John, do you like music when you study? Silas? Yeah. Okay, so here's what we would do. Imagine we do this with every single person in the class. All the no's go over there, all the yeses go over here, and we compare your test scores. Everybody good? In that case, was the group that we did the study on randomly selected? No. Did I randomly assign you to the treatments?
No.
And the treatments would have been the music, no music, yeah? Okay. It would be what divided the difference between the two groups, right? Okay. All right, so in this case, let's go ahead and say there was a big difference in the music to no music group. Here's what we can say. There's a difference between the two groups for Miss Meister's. For AP Stats students. this is not a nothing conclusion, but it's not a very strong one. Because we're not saying that the music caused those differences, okay? And now, when we look at this next one, this time instead of doing just AP Stats students, I do the exact same thing, but I do it with a random sample of kids from the school, okay? So now, did I have random assignment? No. Did I have random selection? Yes. So here's what changes there then. There's a difference between the two groups. There's a difference between music and no music. For all of Grandview Heights High School. I have a random sample. If the sample was drawn randomly, I can assume that it is representative of the whole school. Okay, let's look at the next one. Get all the students to participate. Randomly assign half of you to listen to music while studying, and randomly, you guys get what I'm saying. I'm not being very articulate. So we had random assignment. Okay, so the change in conclusion would be listening to music while studying increases grades. That's that cause-effect relationship, okay? Now, can we conclude this about everybody? No. So now we conclude cause-effect, but we can only conclude it for AP Stats students. I got one more scenario. Do you guys want to guess what's going to happen in this scenario? Are you guys shocked that both answers are yes? Is that surprising? Okay, so what do you think this changes my conclusion to then? Okay, so now we can say listening to music causes higher grades.
Do you like Wendy's for lunch?
No, thank you. I brought my own.
I thought you had something, but I'm going to get a Krabby Patty lunch.
Well, I would have Wendy's for lunch if it weren't for tomorrow's cluster truck day, so I don't want to save that for tomorrow either. Obviously, this is the strongest conclusion, right? Because I had the most randomization, so random is good. So when we think about, when we're making an inference at the end of a study, we want to be thinking about it in two capacities. Who am I concluding it about, and what am I concluding? Based off of what I was told. Are we good? All right. One last thing. Okay, a long time ago, early 90s, cars did not have, you know how now, at the top of a window, there's a brake light? Do you guys know what I'm talking about? At the top of the back of any car, okay? It didn't used to be that way. The only brake lights were the two underneath your taillights. Are we good? Okay. So, they did a study, and to decide, did adding the third brake light decrease accidents? So they looked at accidents on the whole, and then they looked at accidents with cars with that third brake light. And they saw a huge dramatic shift in the proportion of accidents for those cars. So, of course, they added that third brake light to every car. Then what happened at the end? it really only led to a 5% drop. Even though, but like in this study, it was a 50% drop in accidents. But in real life, it only led to a 5% drop in accidents. So why do you think that would have happened? Why would the study be so different comparatively to what happened once all the cars had them?
Maybe it didn't factor in highways where you have less time to react.
The study was done on highways too. Like they just they had people do their typical driving. Okay, now. They randomly chose their people, right? Like it was they had a representative set of drivers. Here's what happened. When there were only like a few cars on the road that had that third brake light, you noticed it. But when there were every car on the road had it, then it became like you didn't notice that third brake light. Does that make sense? Okay, so in this particular case, the study couldn't model real life. Like you can't get the picture of when every car has it because not every car has it. Do you guys get kind of like the gist of that? The other thing is when it comes to experiments, not all, like experiments go through a process where they get reviewed by other people, okay? It's called an IRB. You don't need to know about it, but I'm going to tell you about it because I want you guys, like, could I design a study to decide, does texting actually make you get more likely to get in a car accident? So this is what I'm going to do, okay? Flip a coin, leva, heads. You have to text while you're driving, and tails, you don't need to text while you're driving. And could I run that experiment? Does that seem like a good idea? Probably would not be ethical. Likewise, there has never been a study on smoking. There have been plenty of studies on smoking. They have not been experiments where people are randomly assigned to having to smoke and randomly assigned to not having to smoke. You guys with me? Because you can't assign a treatment that you think will be dangerous to another person. So they do other studies instead. For the texting, they might present to that IRB, and the IRB says, no, what you're going to do is have people drive in a simulator. Like a fake car. You know what I'm saying? And text. So that they're not actually at risk. So the IRB goes through and says, they look at two things. Is it safe for people? And is it... it will actually answer the question. So the IRB was wrong to not send this study back. Because but on the flip side of that, I don't know that there is a good way to study the taillights like this. Unless you do it in a simulator with fake cars. Make sense? Now, do you guys believe that smoking causes cancer?
Yeah.
Okay, good. Now, just because we didn't have the experiment, do you know how many observational studies have been done? A ton. And they all come up with the same results. And so there's still, like, in longitudinal studies, we can still end up concluding some cause and effect. But in your guys' brains, I don't want you, like, it actually still does happen that we conclude cause and effect without experiments, but not in the idealized AP statistics world. Okay? In the AP statistics world, if you don't have an experiment, you cannot conclude cause and effect. Everybody good? Sweet, I'm done.